Hi everybody, this is section 4.3 on quadratic functions from our Hawks Learning College Algebra textbook. As we have mentioned before and talked about quadratics before, a quadratic function, f in the variable x, is a second degree polynomial function. It's second degree because the highest power of any term is 2. So you have that typically that x squared term. And the standard form of a quadratic function is ax squared plus bx plus c, which we have looked at with factoring and completing the square and using our quadratic formula to solve. Now what we're really going to do is focus more on the graph of the quadratic. Right now, one new thing we're going to look at is the vertex form of a quadratic equation, and your vertex form is going to be, g of x or h of x or f of x or something of x but it's always going to be a times x minus h squared plus k, and our a, h, and k are real numbers. A can never be 0 because 0 times anything is 0, so that would not make it a quadratic. And your vertex of your parabola, and again, your parabola, if you recall, when we graph a quadratic, your parabola is that U shape. Okay, the vertex is either the minimum or the maximum point of that parabola. And the vertex is always labeled HK. Now, if our parabola is narrower than x squared. So if you were to graph x squared on your calculator, or just look at the standard parabola. The one I drew wasn't fabulous. Let me see if I can make a better one. It looks something like this. Not fabulous, but a little bit better. Anyways, if the absolute value of a, so it doesn't matter if a is positive or negative, but if a is a number greater than 1, the parabola is narrower. So the bigger the number, the narrower the parabola is. But if a is, say, a fraction, it's between 0 and 1. If a is, again, between 0 and 1, that parabola is broader. So like a fraction for a will actually make that parabola look a lot wider, and a whole number like 2, 3, 4, anything greater than 1 will make it narrower. Now, if a is positive, your parabola always opens up, and if it's negative, it opens down. And we're going to take a look at that in a couple of the slides. All right, so here we have the quadratic function negative x squared minus 2x plus 3. And they want us to locate the vertex and the x-intercepts. Now, by looking at it in standard form, I can't tell you what the vertex is or the x-intercepts is just yet. But I can determine whether my parabola will open up or down. Remember, the a value tells us if it opens up or down. Here, this is a, it's -1. So because it's a negative, my parabola, wherever the vertex is, and again, I'm just going to sketch it, is going to open down. Okay, so I know that it opens down. I don't know where the vertex is. I don't know where the x and y or the x-intercepts are, but we are going to find that. All right, so now what we are going to do is we are going to find the vertex of our quadratic function that they gave us. The easiest way to do this, if it's in standard form, is to find the vertex by looking at the values of a, b, and c. So to find the vertex, probably the way that you're used to is right here. We do, for the h value, the opposite of b divided by 2a. And then to find the k value, what you would do is you take whatever value you get for h and plug it into your function. So it's saying like f of whatever that number is. Now, sometimes that y value, like if x is a fraction, it makes it a little bit harder to solve. So if that is the case, there is another way to find the y value so you don't have to deal with like messy fractions, and that is to do for h the opposite of b over 2a, and then for the y value we are going to do the explicit formula, which is 4 times AC minus b squared over 4a. So it's similar to that quadratic formula, but not quite. And again, that is our explicit formula. So I'll write that out for you. I know that did not turn out very well. All right, but again, you can use either you can do the first part if it's easier, or you can do the second part for finding y or k and use that explicit formula. And we're going to take a look at both. And then once you find the vertex, the x-intercepts is also another great way to help you plot and graph, excuse me, your quadratic function. So we're going to go back and we're going to take a look at our first quadratic function where they wanted us to find the vertex and the x-intercepts. So the equation that they gave us was negative x squared minus 2x plus 3. And again, to find that vertex, we're going to start off, we're going to do the opposite of b divided by 2a. So the opposite of b is negative 2, so we would have 2 divided by 2 times negative 1. So that's going to give me 2 divided by negative 2, or a negative 1. So that is going to be my h value. So for my vertex, I'm going to label it with a v. We have negative 1, and we got to find the k value. So again, there's two ways to do it. You can substitute in h into your equation and do the math, or you can do the explicit formula, which we talked about earlier, but this one, negative 1, is pretty easy, so we're just going to plug it in. So that is going to give us, we have the opposite of negative 1 squared minus 2x plus 3. So when I do the math, if I square negative 1, I get 1. But then the opposite of that is going to make my answer negative 1. So I have negative 1 minus 2 times negative 1 plus 3. So, and I forgot to put my negative 1 up there. Negative 1 minus 2 times negative 1. That will give me negative 1 minus negative 2 plus 3. Negative 1 minus negative 2. We'll make that plus a positive. So we end up with 1 plus 3, and that is going to be 4. So my vertex is negative 1, 4. Now we got to find the x-intercepts. We've actually already looked at how to find those x-intercepts. When you solve a quadratic, you can either use factoring, completing the square quadratic formula. Those are how we find those x-intercepts. It's where it crosses over the x-axis. So first, I'm going to start with factoring because that's a little bit easier. And what I want to do is to find my intercepts. I am going to, I don't want negative x squared to factor it, so I'm going to multiply everything by negative 1 to get rid of that negative there. Because when you do that, you're just going to basically change the signs, but you're going to get rid of that negative x squared. So it's going to be, if I multiply everything here by negative 1, I am going to end up with x squared plus 2x minus 3. And now what we're going to do is look at how we can factor that, if it's factorable. Sometimes it's not. I know that I can have x here and x here. 3 and 1 is the only way to make 3. So I need a positive 2 and a negative 3. So let's do plus 3 minus 1, which will give me a positive 2x. And then what we do is just x plus 3 equals 0. X minus 1 equals 0. Solve my equation, so subtract 3. So x equals negative 3, and then add 1 here. So x equals 1. So that means that my x-intercepts are negative 3, 0. So the y value is always 0 there. And 1, 0. So those would be my x-intercepts for this equation. And here on the slide, you can see they've sketched the graph. We have the vertex, which was at negative 1, 4, and then our two x-intercepts, which are at negative 3, 0, and 1, 0. All right, so now we're going to look at two more standard form for quadratic functions, and we are going to find the vertex for each of those. And again, we'll use either the simple formula if the h value is simple, or we'll use the explicit if it's a little bit harder or like a fraction. All right, so we're going to start off first and do our h value, which is like our x value. And remember, that is the opposite of b over 2a. So we'll do positive 4 over 2, and a would be 1. So we have 4 divided by 2, which is going to be 2. Now, 2 is a pretty easy number. So now what we're going to do is we're going to find f of 2. We're going to plug in that x value to find the y value or the k value for the vertex. So we are going to do 2 squared minus 4 times 2 plus 8. So we have 4 minus 8 plus 8. Well, 4 minus 8 is negative 4 plus 8 will give me a positive 4. So my vertex here, my hk, is going to be 2, 4 for that quadratic. All right, and now for our second one, to find h, again, we are going to do the opposite of b. So I'm going to make it a negative 5 over 2 times 3. So that's going to give me negative 5 over 6. Now, this is a fraction. It's a little bit harder to deal with. I don't necessarily want to do, g of negative 5/6 and plug it in. I'm going to deal with a lot of fractions. It's going to be messy. So we can do our explicit formula to find k. Remember, that explicit formula is 4ac minus b squared over 4a. So we'll make life a little bit easier on us. So we are going to do 4 times 3 times negative 1 minus 5 squared over 4 times 3. So let's see. On the bottom, we will get 12. 4 times 3 is 12, times negative 1 will give me negative 12 minus 25. And again, we can make that plus a negative 25. So negative 12 plus negative 25 is going to give me negative 37 over 12. So that was definitely one where using that explicit formula helps out quite a bit, because my vertex here is negative 5/6 and negative 37/12. So to have those two fractions there and relatively easy calculations was nice, instead of trying to plug in the 5/6 to get that 37/12. All right, so here what we are going to do is we are going to look at the quadratic graph and we're going to find the formula for this quadratic. So we're going to find it. We'll start with probably vertex form, and then we can go to standard or go to standard first and then vertex. And we are going to then also use that formula to determine the coordinates of the parabola's vertex. So one of the first things you want to look at is, the vertex, not easily identifiable. We can kind of estimate what it is, but we don't know for sure because it's in it's in that middle of that square there. But my x-intercepts are pretty clear. I can tell that the parabola crosses over the x-axis at -1 and at 2. So remember before we factored, and that was how we found our x-intercepts. If it crosses over at -1 and 2, that means that this parabola can be formed with x plus 1, because remember it would be the opposite, times x minus 2, because if I were to solve those, they would give me the opposites of each. And then we don't know right now. What we need to find is the a value. Now, I do know the parabola, it opens down, so I know a is a negative, but I don't know what that a value is. Just writing, the x plus 1, x minus 2 isn't going to give me the total formula, but it will help us out. Now, what we do need to do is, let me erase this a little bit, is we want to find what our a value is. So we can determine that by looking at basically where our parabola, like an ordered pair that we know, or a y value. I can see right now that one ordered pair that I know is where it crosses over that y-axis. All right, so it crosses over the y-axis right there, and that ordered pair is 0, 4. So that means if I were to calculate f of 0, it's going to equal 4. The y value would be 4. So here's what we're going to do. We are going to take that and we're going to plug it in to our equation for x. So I'm going to say I have a times, and instead of x, I know my x is my 0 value. I'm going to put 0 plus 1 times 0 minus 2 equals 4. And again, I found that ordered pair. I plugged it in for, because remember it equals f of x or y. So I put my x values in where x was and my y value where y was. Now, let's do the math. We have a times 1 times -2 equals 4. So we end up with -2a equals 4. Divide by -2, and then we're going to get a is equal to a -2. And that's good that it came out negative because we know it should be. So now what we're going to do on the next slide is put it all together. All right, so we found an ordered pair that we knew and we used the y-intercept. So we knew our ordered pair here, right here, was 0, 4. And then what we did is we took that 0, 4 and we substituted into our equation for x and y. And remember, f of x is the same as y. So we really did this. We did y is equal to a times x plus 1, x minus 2. And instead of x, we plugged in our zeros for x. and we knew y was 4. And then we solved for a. So let me put that a back in there. Okay, and we ended up with a equals a -2. So now when we write our entire equation, we can put it in. Right now we have this. We have f of x equals -2 times x plus 1, x minus 2. But right now that's not in vertex form or standard form. So really what we need to do is multiply it out to get it into standard form. So I'm going to start by distributing that -2. So I'll have -2x minus 2 times x minus 2, which we would then FOIL. And I'm kind of running out of room here, but once we FOIL it, we are going to get f of x equals -2x squared plus 2x plus 4. And from there, once we have that, now we can find the vertex. So let me erase a little bit over here. All right, so we got the standard form of the equation, and what we want to do now is find the vertex of that equation, because that's what they ultimately asked for. We found this equation, now we're going to find the vertex, so I'm going to do the opposite of b over 2a, so that means for h we have -2 over 2 times -2. So it's going to give me -2 over -4, or 2 negatives make it a positive 1/2. And again, because we do have that fraction there, let's use our explicit formula. And so we are going to do 4ac minus b squared over 4a. So let's do, so k, we're going to do 4 times, I'm going to switch to a different color, -2 times 4, that's 4ac, minus 2 squared, all over 4 times a, or -2. So that is going to give me, for k, 4 times -2 is -8. -8 times 4 is -32, minus 4. So we have -32 minus 4 over -8. So we end up with -32 minus 4 plus a negative. So it's going to be -36 divided by -8. So that we can simplify down, and we can divide them both by 4. And that would give us, and 2 negatives are going to make it positive. So it will be 9 over 2. So my k value is 9 over 2, which means our vertex, which I'm sorry it's a little crazy here, is 1/2 and 9 over 2. All right, so next we're going to look at a word problem to kind of with quadratics. In here we have a farmer, and he plans to use 100 feet of spare fencing material to form a rectangular garden plot against the side of a long barn. So again, don't judge on my drawing. It's not fabulous, but here's our barn. All right, there it is. It's the roof of the barn. It's beautiful. Anyways, so he's going to use the long side of the barn as one of the sides, and then how should he split up the fencing among the other 3 sides in order to maximize the area of the garden plot? So we're going to draw it in blue. Our garden fence is going to go out from one side to the other, and they know that they want a rectangular garden, so opposite sides will be parallel and the same length. So they're not going to make any crazy designs. Now, we are looking at the area of the garden. So I want you to think, the formula for area is length times width. I don't know my length and I don't know my width, but I do know I have 100 feet of fencing. So what we are going to do is, I'm going to call the two sides that are the same or parallel, I'm going to call those X, because I don't know what they are. But I do know that they're the same length. Now, we have to find that other side. So this is our, X is going to be our length. So, X equals the length. And the width is going to be 100 minus 2x. Now you're probably like, where did you get that from? Well, I know I have 100 feet of fencing, and if each side is x, I'm going to take and use that amount. So then what I have left over for the width would be 100 minus 2x. All right. So now what we need to do is we need to put this together into a problem so we can solve it to find the maximum area of the garden plot. So what we're going to start off to do is we're going to use our area formula. Oops. We are going to do area is equal to length times width. So I know my length and I know my width. So our formula for this, our area is equal to x times 100 minus 2x. And we can simplify that. So we're going to multiply. So we are going to have 100x minus 2x squared when I distribute there. And that is our quadratic that we're going to use. And we now have enough information so that we can find the vertex of our parabola. And you're probably like, well, that's great, but how's that vertex going to help us? Remember, when you graph a parabola, and here my A is a -2, I know that parabola is going to open down. That means that my vertex, whatever it is, and again, I just sketched that as not true to the problem, that's going to be my maximum value. And I want to know how I'm going to maximize the area. So I need to find that vertex to help me out. So we're going to flip to the next page and find that vertex. All right, here we have a much better picture of the fence for you to look at. And we found, again, that our equation was area was equal to 100 x minus 2x squared. I'll put my x there minus my 2x squared. Now we're used to seeing this in standard form, so we could make it -2x squared plus 100x if that helps. To find that vertex, and again, when we graph it, it's going to be, it's a -a, so it's going to open down, so that vertex is going to be our maximum value. So let's do the opposite of b over 2a to get my h value. So the opposite of b would be -100 over 2 times -2. So it's going to give me -100 divided by -4. And that's going to give me 25. So h is 25. Now we do need to find k. So, and again, 25 isn't bad. Let's plug it into the problem to find k. So we are going to do -2 times 25 squared plus 100 times 25. Okay, So when we do 25 squared first, it is 625 times the -2. So I get negative 1,250 plus 100 times 25 is going to give us 2,500. And when we add those together, we get 1,250. So that's my K value. So let's look at this vertex. Our vertex right now is 25 and 1,250. Now, how does that help me with the problem? Okay, remember, X was our length. Okay, so we want to know what the maximum length could be. We want to know the dimensions. So we know that our maximum length, or X, highest it can be is 25 feet. And so this would be 25 right here. Now, if we were looking for the width, we just have to plug it in. 2 times 25 is 50, so this would be 50. So 25 times 50. And if you notice that if you're trying to interpret what is that 1,250, okay, this is our Y value. That is going to be what the maximum area is, because Y represents A, or the maximum area. So the 25 is our dimension, or what X could be, and then we can use that X to find the other dimension of 50. 25 times 50 gives us 1,250, so this is the actual max area. So this is your max area, and 25 is your maximum length. And you will see some more problems on homework and in the classwork for this week where you look at and investigate what does that vertex tell you in context with the problem.